All right, gang, let's talk about one of my favorite aspects of 802.11n and AC, and that is Mimo. M-I-M-O, multiple input, multiple output. All right, but before we talk about Mimo, we got to go back to its antecedent, which is CISO, single input, single output. Now, when we have, let's say, an 802.11g client, like we see over here, and an 802.11g access point, they are able to communicate from one antenna to another. In other words, we're going to be, again, having a single input and a single output. We input this signal, we output it on the other end. That's it. We have a transmitter, we have a receiver. But wait, this access point has two antennae. True, but remember with the legacy protocols, it will only utilize one of those two antenna for transmit and receive. It will not use more than one. There's simply going to be one set of antenna associated with the client and the access point connecting to each other. So remember, you have an issue there with multipath. When signal is bouncing off of reflective surfaces as well as going straight, you end up with signals showing up at different times, out of phase, corrupting the original signal, like noise-canceling headphones. Bad news. And so you really have a problem with this configuration. Performance improved by diversity. Again, you can have multiple antenna, which does help to pick the best one, but you're still just using one. Now we move to Mimo. All right, this is what we have when we have an 802.11n or an 802.11 AC configuration. What we're going to do is have several antennas on each side, preferably. Could just be a couple on one side and one on the other, but in a best case scenario, it is truly multiple input, multiple output with multiple antennas working on each side. So we've got multiple antenna there, we've got the multiple antenna there. Awesome. So we're going to transmit signal on both of these antenna, and we're going to receive signals on each antenna. Okay, but what's happening? Well, it depends. There's a couple of flavors that can happen with Mimo. One is a strategy focusing on redundancy. So let's say I wanted to say ABC, 1, 2, 3. That's my key message that I want to send. So I send out ABC 1, 2, 3 out both of these antenna. I'm going to redundantly use both antenna to send this data. When I do that, the signal is going to go across both of these antenna, get received by both antenna, and but we're going to essentially have a link where we're going to be recognizing these and recognizing essentially, oh, I recognize this signal because I'm receiving it with this bounce. I'm ignoring the other signal that has a different bounce. So essentially, oh, this antenna connects best to this antenna, so we'll create an association where we recognize the data that is being sent because it has a particular angle that it's going to consistently be connecting with. Likewise, the second antenna is going to be recognized by the receiving antenna because of the particular angle that that frequency comes in at. So when it does that, then it can take the aggregate values. And if we ended up with, let's say, ABC1 something 3, and that was what we had off of this receive, the other receive ended up with AB something 1, 2, 3. Well, I can put the two together and I get the whole signal, ABC 1, 2, 3. So it provides redundancy. The other thing, though, that can be done is what's called creating separate spatial streams. In other words, I can take this data, ABC 1, 2, 3, and I can create multiple streams of information being sent out. So I could say ABC is going this way, 1, 2, 3 is going this way. They, based upon the best connections, the transmit and receive will have an association from one side to the other. Therefore, I will this receiving is going to receive and process ABC and ignore the 1, 2, 3 because it's a weak signal anyway. The other one's going to receive and process the 1, 2, 3 and ignore the ABC because it's a weak signal anyway. And oh look, I end up with the overall data. But what I do this time, I did it in half the time because I was able to get it done because I was able to use the same channel, the same frequency, but just at different angles of attack in order to send twice as much data. This is why having multiple spatial streams is so powerful in a Mimo-based configuration. Now again, just a little bit of terminology here. The number of antenna that are associated with an access point will be described in terms of its transceivers, transmit and receivers. And so typically it'll be something like 2 by 2 or 3 by 3, referring to the number of transmitters and the number of receivers. It's possible that you might have two transmitters, 3 receivers, right? That's it. Possible you might have a configuration like that. Again, know that transmit comes before receive. If that access point has the capability and is using spatial streaming, where it's actually dividing this up, then we would see it referenced like this, 2 by 3:2. So 2 transmit, 3 receive with 2 spatial streams available. So it can take out and divide that data. Depending on the protocol that we're looking at, we could end up with a 4 by 4:2:3, even with the latest version of AC. A wave 2 AC could be four spatial streams possible. So really dividing up that data, now it's taking only a quarter of the time to send that same amount of data. That's why the throughput goes through the roof when we start having multiple antennae and we can divide the workload up. It's very stable, very efficient.